I am Matt Sharp. I work at Shopify. I'm a data developer there, a very generic title, but essentially machine learning engineer. And I don't drink coffee or tea, so I'm a water guy for sure.
Welcome back to the MLOps Community Podcast. I am your host, Dimitri Os, and I am here with one of the best in the business, Abi. How's it going, Abi?
Great. There's a lot happening in the tech world. Too many changes, too many improvements, way too many announcements. We had a wonderful conversation with Matt. Matt is a chemical engineer turned data scientist turned data engineer. And right now he's leading data at Shopify. So I think I'll let Demetrius take on. What were your favorite parts of Demetrius in the conversation?
Well, for those who don't know, Matt also is a bit of a LinkedIn influencer because of all of the conversations and posts that he has up around clean code for data scientists. He refers to himself as a recovering data scientist. And we got into that in this conversation. We also talked a little bit about the platform that Shopify created, Merlin, and the blog posts that they wrote about it and how they're able to enable, there's a little bit of a tongue twister for you, the real-time recommender systems and the inbox classification and also fraud detection, all that good stuff that you hear about for real-time use cases. They break down exactly how they're doing it. And also, I think the biggest takeaway for me on Merlin and the whole real-time serving platform that they created was the ability to quickly iterate and get up and running with a sandbox. And then if you prove out some value, you can go and run with it. That was my takeaway. What about yours?
So for me, I think I loved his advice on what does clean code mean for data scientists.
I thought he had a hot take about those posts that blow up on LinkedIn and Twitter. Like, I've been a data scientist or a software engineer for X amount of years, and I still Google how to do the most basic things in Python. And his response to that was hilarious. It was like, if you've been a data scientist for 12 years and you're still figuring out the basic building blocks of Python and you have to Google that, you're not good at your job. So let's just be very candid about that. And I thought that was a funny hot take that is a little bit contrarian to the things that we see and hear on social media.
So overall, I think the conversation was a good combination of talking about clean coding practices for data scientists. And then we moved to real-time streaming, talking about Merlin, and then finally to LLMs in production and some of his work on the topic and some of his opinions. So overall, there's something for everybody. He
is coming out with a book too on LLMs in production. I think that is actually the title of the book, and it should be out soon. If it is out already, we will leave a link in the description. If it's not out, we will hopefully leave a link to the early bird version of it so that you can check it out. And without further ado, I think it's time to get into this conversation. If you like and enjoy this podcast, it means the world to us if you just share it with one friend. One friend, that's all we ask, because that is the way that we're going to spread the good word of MLOps, or as some people are calling it these days, LLM ops, or as other people are calling it these days, LLMs in production. And we've been having all kinds of LLMs in production conferences happening. And I think by the time this bad boy comes out, we are going to either be gearing up for the LLM in production conference, which you can find a link to in the description below, or we're going to just have had it, which you also can find a link to all the replays in the description below. So depending on where you are at in time when you listen to this, you can click on the link below and get everything about LLMs in production to your heart's desire. That's it for now. Let's jump into the conversation with Matt. First thing I want to know, to start it off, do you have a really big wall in front of you that you watch? You have a projector behind you, and I'm guessing that it's your home movie theater that you project onto a wall. It is?
I knew it. Yeah, so we, just on the second floor across the living room, there's just this empty canvas, and So yeah, we'll have home videos and stuff up there. So it's pretty nice.
Oh, that looks so cool. Yeah, well done. Well done. All right. Matt, great to have you here. I have been a fan for a while. You've been preaching the good word on LinkedIn about clean code for data scientists. I think it struck a nerve because occasionally I'll see one of your posts pop up with thousands of likes and views and all of that good stuff. So you are a bit of an influencer these days, and I think there's a reason for that. Lots of people have either been a data scientist or work with data scientists that may or may not know the fundamentals. And so it's very important to get it right. And you are trying to raise awareness about this. What brought you into this space? Like, why did you decide that you were going to be the one to start talking about this?
Well, I guess, I mean, to start off, like, I used to be a data scientist myself. So, like, I get it. Like, when you're a data scientist, there's just like so many things to learn, like statistics heavy and just like analyzing data and just being able to answer stakeholders' questions and answer the business values and all of these things that oftentimes the actual code portion is often seen as like, well, I got it working. Like, that's fine. But like, at least when I was a data scientist, there were so many errors and wasted time because like I had to go and fix some bug or do other things. And like when I was there was no one around me who knew coding, so like it was mostly just me and, some other data scientists, trying to hack things together. And so, and then like, I go to a tech shop and like it's completely different, right? So like at at Shopify, for example, like when do you think they start expecting like a data scientist to start writing clean code? And and like the answer is like immediately, right?
Yeah.
Like if you go in and you look at like our documents of saying, okay, hey, like you're a senior engineer, like these are the requirements for your job, like clean code is actually inside, like being able to write clean code is inside of our requirements, and it starts as an intern, right? Like, because like when you come in as an intern, they don't necessarily expect you to be able to solve problems, but they do expect you to write clean code. So like it's very much a fundamental problem that needs to be there right at the beginning. And I don't think a lot of data scientists like realize that.
One very quick question, because I want to clarify this for our listeners. There's a lot of conversation about writing clean code, but what does that mean for you? Does that mean the use of functions or writing modular code? Does that mean writing unit test and integration test while writing the code, or does it mean structuring all of those things? What are your top tips for when you say, okay, this passes my mark for clean code?
So like clean code to me, like the definition is how easy it is to understand. And so the best way for you to gauge it is if you write code and you come back 6 months from now, when you completely forgot about what you were working on, can you get caught up within a couple of seconds or minutes? Can someone else come in and read your code and understand it? Right? Clean code is all about the communication aspect. It's very much a technical skill, but it's a lot more of a soft skill. Because the whole point of clean code is making sure that you can collaborate with other people. So like, because you don't work in a vacuum, right? You need to be able to communicate with analysts and other data scientists about the statistics and about how you're working with the code. And then you also need to be able to go in and hopefully you're going to be working with, data engineers, ML engineers, and other people, and they need to be able to talk. And like the code is really the communication piece of how this all works down. And so like when code is clean, it's communicatable.
And how do you define clearly communicable code? Does that mean it's well commented, or does that mean, you are using the right variables, which is the the function naming is done in a way that makes sense instead of using very random variables to be able to store things. How do you define, or what are your three top things that you would say are important for that?
So naming variables is definitely probably the largest aspect of writing clean code, just because if the variables are well written and well defined, like you just, like if you read a model called cars, right? It's just like, well, what could be in there? And it gets, I think a data set that I often point to is, so like at my old company, we had a table called locations. And like locations sounds like a great name, but like what does it mean, right? Like
Yeah.
it can mean, because like we had locations for like merchant addresses, and then we also had online locations, which were just websites, and just like it got really confusing. And the problem is that this locations table, like people put it up and it was actually zip codes, and we never used it. And so like, but it was up there and it got integrated into a bunch of different things. And so like, no one wanted to touch it and remove it and clean things up, but everyone would always try to, merge onto that table and like get their location data, and they thought they was all groovy, and then they would be like, wait, why isn't this working? Why is my data analysis like not working? And it's just like, well, it's because you're using the locations table, which, isn't our locations. You
Locations
actually,
aren't locations.
right, like you want, merchant addresses, right? And so, but like, so a good name is both like very like particular, but it's also broad enough to include all the use cases of what you're trying to do, and kind of understanding that and getting a hang of good names is obviously really important. I think there's a common joke where it's just like there are, the two hardest things in programming are naming, cache invalidation, and off by one errors. But like, so yeah, so naming is definitely hard, but I think oftentimes when you talk with data scientists though, is that like most of them don't necessarily come from a computer science background. And so a lot of the tips I give often involve just like, how do you structure a project so that way you can find the files you need? Like how do you, um, and because that comes down to the communication, right? Because like if I'm given a project, a Ruby on Rails project, like Ruby on Rails has this awesome structure where like, it has scaffolding. And so every project is exactly the same. It's really easy to find, okay, here's where the JavaScript, here's where the controllers are, here's where the views are. It's really easy to go in and dig into them because they're all the same. But like, like data science projects often don't have that type of scaffolding or other things like that. And so like, it's really hard to find even like basic things. And like, where are the tests? Oh, like, do they even have tests? Oh, okay, no, like this is a data science project. I forgot. It's like, and then like they
Oh,
have, and just like a lot of the problems often stem from like, data scientists are always using Jupyter notebooks, right? And but like they haven't learned the computer science aspect, so they don't know how to like manage those, and they often get lots of different naming, and so it's just like figuring out the best. And so a lot of my tips often go into that of like, okay, like this is how you get the most out of your Jupyter notebook. This is how you can communicate more, and other things like that.
dude, I love it. I mean, coming out hard on the data science projects, and you went there, so I'm going to follow your lead and ask about Jupyter notebooks and things that you've found, because I actually enjoy finding out about other people's processes when it comes to taking Jupyter notebooks and all of the power that they present in their phases of the machine learning lifecycle. But then what do you do once you've reached the end of their life cycle, and how do you get out of them as quickly as possible? And what do you recommend to the data scientists then? If ever, because some people I know don't like to get out of them.
I've spent enough time in Jupyter notebooks that I'm really not a fan. Everything from managing their kernels to like just, like the tricks, you can play. Um, and this was actually, I don't know if it's April Fool's, but it was just like, hey, like this is a prank I played where, you go in, you run some code, and then you delete that cell, and like no one's ever going to be able to understand why like their Jupyter notebook works and it doesn't work anymore just because you like redefined, some imports or things like that. And so generally how I like to use a Jupyter notebook though is because like they are powerful. Like you can iterate really quickly, you can go through and you can get things, um, you know, look at your data easier, they are really powerful. But so I like to use them, and I think this is really useful is essentially like I think people make their cells too small. They're often, you often want to make them do one thing, but like a cell isn't a function, right? Like there's no restriction for it to doing one thing. But so what I like to do is I like to think about cells as like if I was to put this into like a scripting project and inside of just pure Python files, like a cell would be a single file, with its separate imports and doing its own specific thing, usually like defining a class or defining a group of functions that I can then like import into other cells. And so what makes this strategy powerful is generally like by the time each cell is encapsulated, and you can be ensured that each cell will be able to run on its own. The next powerful thing about doing this is that when it comes time to like communicating or maybe moving it into a more foundational, Python script or library, like it's just a matter of taking each cell and copying it into like a script file, and then just making sure you adjust the imports to include the other things you need. And so um, I find that strategy really powerful as far as transitioning between a Jupyter notebook and an actual project, as well as just like making sure things are clear and things always run and work well.
I think this is a really interesting nerve that you're hitting, which comes down to this difference between doing just an exploratory project where you're just exploring the data at the first level, trying to understand, make sense out of it, versus when you're writing code for production level. And while you can do it in anything, you can write it in a Jupyter notebook, or you can choose to write the Python code from the get-go. But I don't think that distinction is usually mentioned clearly, which is, there's no problem with using any tool. The problem is how you write at different stages of using that tool. So while writing module code is a little bit more important when you're writing production level code, do you think it's equally important when you're doing exploration as well? Or do you think, the cell code is, okay, we can keep using the df shape and just run that while we're doing exploration, and maybe once we're writing the production level code, that doesn't really fly?
I talk about this a lot. I think clean code should be right at the very beginning, no matter what you're doing, because exploratory data analysis, like the workflow I see data analysts do all the time is, okay, I have a new exploratory data analysis, I create a new Jupyter notebook, and then the first thing they do is they go find their last analysis and they start copying the code over, right? Like, oh, I don't want to redo this again, right? But like that first code they wrote being like, oh, this is just a quick script, and it's really bad. And then they go and they copy it over, and then they're like trying to, run it, and they're like, oh no, I made a mistake, and now they go and they make fixes, and then they make edits, and it's just like, no, like just go. And then this is actually something I recommend is like have a Jupyter notebook that is like 4 notes, like actual notes, right? Like you're gonna go and you're gonna copy and paste. Okay, this function was really useful. Copy and paste it over, give notes about what it does, and like clean it up, and then like when you go and you are going to copy code, you're first going to look at that notebook that has all your clean code. It's going to have all your reference stuff in it, and that's going to just, and then you're copying over, and things are just going to go a lot smoother when it comes to a quick analysis, right? Because like no quick analysis is ever like quick.
Yeah.
Like, and so it's almost more important to make sure your code is clean when it's quick and when it's supposed to be an exploratory data analysis. Because one of the things software engineers have learned is like when you're writing code, like you yourself are reading it about 10 times more than you're writing. You're scanning up, you're looking up, oh, what did I set this at? Okay, what is this variable? And so every code is read way more than it's ever written. And so that is the important part of why clean code is good. And clean code is way more valuable for you, right? Like it's future you, whether or not that future you, earlier I said 6 months, but you will find value 5 minutes from now, right? Like when you're coding and you're just looking back up, you're like, oh, what did I do up here? What did I name that variable? And so good clean code is useful. And this is often one of the values of actually working in an IDE versus, just a general Jupyter notebook, because IDEs come with all of the helpful, code completion tips and other things like that. And so I often encourage data scientists, hey, go open up an IDE. It's fine if you use Jupyter notebooks and you love that, but open it up and realize what tools and what things are there and ready for you out of the box, because it'll definitely change your life.
Yeah, it's so interesting that you point that out, like the foundation and how just us as humans, we're so in a hurry all the time to get to the next thing or try and figure something out that we do these quick hacks and then we just start throwing something on top of these quick hacks. And that foundational level is so flimsy that it can end up coming back and biting you in the ass real quick. And so I want to ask one more thing before we move on to the, actually, so one of my most popular posts on LinkedIn was about streaming data in real time, and that seems to blow up. I wanted to ask you before we jump to the next one, what has been your most popular post on LinkedIn thus far? I imagine it's around something clean code.
So this is interesting. So I think my most popular post ever was taken down because it was too controversial. And
taken down by who? You or LinkedIn?
By LinkedIn.
No.
Yeah.
About clean code? About data scientists? Some data scientists at LinkedIn got picked.
So it was yes. So it was a very simple, very, very simple. All it was, and I'm known to be a little controversial sometimes, but all the post said was, clean code is greater than clean data. And it kind of blew up. And a lot of people were really angry with this. But my basic thought process around this is just clean data comes from clean code. All data ultimately comes from code. When whether or not you're taking a video, a digital camera, all of that is code working under the hood to get the data, and then you're putting into a database and you're using data pipelines and you're doing all these things. And so there's just this point where they say 80% of a data scientist's job is cleaning data, and everyone was always saying, hey, data is so important, you have to clean it, garbage in, garbage out. And it's something that data scientists understand very well, because when their data is bad, it just ruins their day. It makes the analysis way harder, it makes training models really harder, but they don't want clean code, because that's work that is on them to do. But it's just but if they had clean code, their data would be cleaner, right? And this is something, with things like what Chad Sanderson's pushing out with, models and APIs, and just, having data contracts and things like that. It's just if you just had clean code and data contracts and these other simple principles, you're going to have clean data. It's going to be a result of it. And so anyway, so yeah, it was just a very simple post. Clean code is more important than clean data, and it just blew up. And I think some people got mad and they took it down because of but yeah, so
that's so wild. I wonder if they took it down because of the comments potentially like being toxic, and LinkedIn doesn't want that to be the experience that people have on LinkedIn, or if it was just some engineer at LinkedIn was like, fuck this, and then they went behind the scenes and were like, delete post.
Yeah, I don't know. It was up for a good while, and like people even took screenshots of it. So like I know it existed, but like I can't find it anymore. And I even had like a direct link to it, and like
Wow.
that just returns a 404. So well, I've been thinking about like re-exploring, reposting it just because it's been taken down. The cult like this was way back when I was first posting about clean code, like it would really upset a lot of data scientists, and like no one thought it was important. But nowadays, like all influencers have found they're like, oh, if I post some like, hey, like here's some good SQL cleaning tips, or like here's some good like the content does really well now, and I see a lot of, and so like I'm really glad that the community has changed and realized like for the hey, clean code is actually important for the better. But like yeah, when I first started talking about clean code, like the only people who I could satisfy was like, you know, old hardened, you know, software engineers. Like, yes, you're finally saying what I've always wanted, right? But like, yeah, I would often have like some head of data science or some VP of data science or something like that say, it doesn't matter, you just need to get it working. But I don't see that as often. So
Wow. It's incredible. Let's take a moment and recognize that this episode is brought to you by Zilliz. Zilliz Cloud is a purpose-built cloud-native vector database that stores, indexes, and searches for billions of embedding vectors to power enterprise-grade similarity search, recommendation systems, LLM apps, and more. It's built on the popular open source vector database Milvus, which if you have not tried out, go check that out too. It's incredible, but easier than Milvus to get started with is Zilliz Cloud. It allows for easy integration with OpenAI, Cohere, Hugging Face, LangChain, Llama Index, and more. It makes it very simple for developers to get started building AI applications that scale from the get-go. Try the new free tier at Zilliz.com/cloud. We'll leave a link in the description. And now let's get back into this episode.
I think now that people have moved from that stage where people were like, can we actually derive value out of, building a machine learning or like a data science team? I think everybody has sort of moved where they have enough maturity to know, yes, you can derive value, but you're not going to be able to derive value out of like bad practices or bad software engineering practices, specifically speaking, because you have to be able to write code that passes the level of at least some best practices on production level software engineering.
yeah, I think this I guess just one more thing before we move on is just like code is where the rubber meets the road for a data scientist. And it's important to realize that like a lot of data scientists think their job is reading white papers all day, and like or like maybe at the end result is writing a white paper. Like that is the, glory, like that is their job, is to write white papers. But ultimately no, it's like it's the right code, right? Like they are programmers, right? Like ultimately, like if they want to manipulate data, if they want to write machine learning models, if they want to do any research on data, like it involves writing code. And that is where the rubber hits the road. And like that, it's just so important to harness their craft and realize like, hey, yeah, you are a programmer. You're a very specialized programmer that does a lot of statistics and does a lot of research, but like you're, like that is your craft, is writing code. It's not reading and writing white papers or whatever else you may think it is, talking in meetings about statistics. No, it's like ultimately like you're like the value you bring people is when you write code.
Yes, you will be held responsible for that. So it's cool that you've talked about it. It's cool that you continue to preach the good word on it, and you're doing hard work, and I'm glad somebody's doing it. I want to go into this real-time streaming. As I mentioned, one of my best performing posts on LinkedIn was talking about real-time streaming. And you all at Shopify just put out a blog post that goes really in depth into how you are doing real-time streaming. And one of the things that I think we can kick off this part of this conversation about is Merlin and what exactly Merlin does, and then how it fits into the rest of your stack.
Yeah, so Merlin is just the machine learning platform at Shopify. And like really, like when you look at it, it's really not much, but it's just a way for data scientists to quickly manage a machine learning project. Of course, and like I say it's not much, but it's really cool. And so like Merlin, the big thing with Merlin is it's built on top of Ray. The main thing is it makes parallel processing really, really easily. And so so the basic principle is it has a head node, which has a bunch of worker nodes. And so like when you start a training job, it'll start spinning up worker nodes to process that data. And so it just makes working with really, really large data sets so much easier. And so Merlin essentially just provides a bunch of command line tools so that way you can quickly spin up a project, manage your dependencies, create your images, and, has some boilerplate code for you to kind of do all this stuff and makes it easy. Specifically, my work stream that I work on inside of Merlin is about making sure that we can do online inference. So we provide a bunch of, helper functions and things like that, so that way you can quickly spin up a new REST API, a new service with your machine learning model, and to be able to have it inside of the Shopify ecosystem and to be able to, get inference out of it. And so it's just really simple. You just, in your terminal, write Merlin services create, and that creates a repo. It creates, simple config files, easy enough, so that way, like, a data scientist doesn't have to go in and mess with Terraform or other things like that, but like they can make sure that they have everything needed, define their, what GPUs they need, how much, CPU and memory. It takes care of all the auto scaling. So one of the recent projects I worked on was adding GPU auto scaling to it. And so, yeah, so that's kind of what my team works on. We created a Merlin pipelines library that just you can import, and then it just has everything you need from getting data from our different data stores, as well as transforming it and getting it into however you need, as well as and making sure that it's all distributed and using Ray out of the get-go. They're now on version 2, and there's been lots of improvements, but kind of working with the team over there at Anyscale, and so there's been kind of lots of learnings. Like one of the things we found is a lot of times, like, data scientists end up often just working on the head node and not taking advantage of the worker nodes and making sure things spin out correctly. And so just making sure that we can make that easier.
So there's one big thing that I want to know, because as you know, I am a happy Shopify user with our funny shirts that we've been selling, which is I hallucinate more than ChatGPT. They've been discontinued because we can't just have them available all the time. We got to put a little bit of scarcity around it. But me as a Shopify user, what are some of the things that like you're working on that I, as that end user, am seeing in my interactions with Shopify?
So there's kind of a lot of cool projects happening under the hood. So like one of the projects that the team has been working on a lot is supporting like not safe for work filtering, because Shopify supports lots of different businesses, and so when you go onto an app, though, you don't necessarily, depending on who you are, right? Like necessarily getting, kind of an adult shop or lingerie shop, or, like a violent, like a gun shop or something like that. Maybe, um, if you're just looking for Lego toys, and something like that, like, or a water gun, you don't necessarily want real guns popping up, right? And so having some sort of a filter there is something the team's been working on and improving, and I've been and so so those are some of the things. The other thing, like we have projects, like, so one of the cool projects I think is like you know recommendations for like new shop owners. So like when you create a new shop, like there's a lot that needs to happen, right? And like understanding, the best path forward to
So
create
much,
your
yeah.
shop, like can be a confusing process. So like we have some models in place that help kind of understand who you are, what type of shop you're trying to build, and then like make recommendations as you go. And we try to follow what you're doing and continue to make the next best action recommendation, so that way you can build and grow your
Nice.
shop more organically. And so that's kind of cool. We also have other machine learning models that just are for internal use of understanding what we call the grid, is just like understanding our own data, and understanding trends, and what should we do? Like maybe should we do different promotions, or should we do different outreach? How should
For
marketing
sure.
work? And so like we do have models internally that help the business do the business things. And so like yeah, there's lots of different um projects. Yeah, Shopify, I think it was said is like, with online or, e-commerce, like there's so much that can be done, and there's so much we can help our shop owners become better at. And so,
For
like
sure.
I think the saying is saying like we're more likely to die from like constipation than we are from starving, right? Like we have, trying to shove
Yeah.
too much in, and not focusing on the highest priorities than we are to be like, oh, we don't have anything to do, right? Like, no, we have so many ideas floating around. There's so many cool projects that people come up with. And so, yeah, always trying to figure out what the highest priority ones are and what can be the most valuable, are always really useful. So, yeah, our Shopify has invested a lot recently into like OpenAI, and we have a partnership with GPT, and so like we've integrated it into a lot of different things that you might be able to see. So when you're creating your store and you want to start adding like products to it, like there's a whole workflow process, and inside of that you can actually add GPT recommendations, right? So like it's like, hey, I want to add sunglasses. And if you add this to your workflow, it'll actually come up with a cool description of like what those sunglasses are, and like kind of be a little bit salesy, or like, hey, like you're gonna look the coolest with
Mhm.
these shades and things like that. It helps kind of automate a lot of those different things, as well as, like, hey, you can use it to like maybe auto generate tags. So saying like what, who this is for and things like that. And so so yeah, lots of different projects happening inside of Shopify to make your job easier.
Yeah, well, I know we're going to get into a lot of that. Hopefully, I can convince somebody at Shopify to come and talk at the next LLMs in production conference, because that would be awesome. Maybe you, maybe somebody else, I don't know. But I want to take these last couple minutes to talk about the book that you're writing. And what book are you writing, first of all, and what made you want to write it?
Yeah. So we're writing a book, LLMs in production, which happened to be the same title as your last conference. So we felt,
Great
pretty
minds think
excited
alike.
that, Yeah, exactly. Yeah, so this is something that's kind of been in the works for a while now. Me and my co-author, Chris Brousseau, um, he's kind of a legend in the NLP community per se. He works at MasterCard, and so it really is a nice pairing because he comes with a lot of that natural language processing background. You know, he's worked as a translator and he knows several languages. Went in and became a data scientist and kind of learned a lot of that. And I kind of come from the other end of, hey, like one of the things I've always been focusing on in my career is like, how do I get a model into production? Like, how do I make it easy for people to use and actually usable? Like one of the things I hate the most is like when someone creates a cool model and it just sits in like their project workspace on their laptop or something like that. It's like, no, I want like let's get this out to the world. Um and so yeah, so we kind of come in from both ends. And so yeah, this book LLMs in production, it really focuses on um how to put and work with and maintain these large language models inside of production. I think we because what kind of inspired this though is like we saw a lot of people talking about writing LLM books, but a lot of it is more focused on the data scientist. It's talking about the theory. It's really going into like how do you train one of these massive models, and you know how do you deal with all those things. So we really wanted to take it the other way, and so like our book is really more geared towards the MLEs, the software engineers, you know, the people who also want to work with these models, but you know, like kind of more get them into a more useful state. And so um so yeah, we're talking everything from, you know, so like there are things we're going to be talking about in the book that, you know, like okay, you know, like what data sets do you need to train an LLM? But like a data scientist is going to care about that question differently from like a machine learning engineer, right? Like a machine learning engineer or a data engineer cares about that in the aspect of like, how do I go and get that data, right? Like, how do I build the data pipeline around it? Like, how do I clean it or web scrape it or, you know, do those things? Versus a data scientist is going to worry more about like, okay, like, how do I clean it? How do I train it? You know, like, and so um, we often have a lot of the same questions, but our reasoning and purpose for them are different. And so yeah, so uh, this book is, I think what's going to be really cool is, so the end of the book, we're going to have 3 different chapters on uh, that allow you to go and put an LLM into production. So we're probably one chapter will be just like, hey, you're gonna set up a cluster in the cloud. You're gonna go in and you're gonna deploy a model into the cloud. You're gonna then, you know, create maybe like a phone app or something, and you're gonna be able to go interact with it and use it. Maybe set up some sort of chatbot. You know, the other project we're working on is um, you know, like code completion, like getting your own GitHub Copilot, something like that, where you can go in, you can just get something maybe set up on your laptop, or again, you had it from the cloud before. So like, can you deploy an LLM that you fine tuned for that and kind of just use it on your own data, you know, so that way you can keep all your code, you know, prevent from pushing your code up to OpenAI. So that way you have more control and making sure it's clean. And then the last one, I think is really going to blow people's mind. So like we've gotten, and there's definitely a smaller part of creator data sets if you will go into Reddit and things like that. But like we've gotten LLMs working on a Raspberry Pi, and we want to show you how you can do that as well, how you can get LLMs onto the edge. And I think that's really cool because when we first started talking about this idea, we're just like, yeah, LLMs on the edge, haha. Like there's like it's not, you know, it's not even possible, you know, several months ago. And it's just like, no, you just have to have like tons of massive GPUs and things like that. But like, you know, like with compression as well as llama and other things like that, you can get a small LLM, you know, 6 million parameters, 7 billion parameters down onto a Raspberry Pi and get it running. And it may be really slow, but like we hope we'll be able to speed that up with like a TPU stick, like with Coral or something like that. And so yeah, we're pretty excited and about this book.
So currently,
I can't wait.
I have a little bit information, which is you've written the initials for chapter 2 and chapter 3 already. When does the early access come out?
So I think the early access comes out after you've written a third of your book. And since we're going with Manning, they have MEAP is what it's called, MEAP, which gives people early access. And so yeah, so we're supposed to be done with our site May 22nd. So hopefully the first MEAP will be soon after that.
By the time this podcast comes out, approximately around that time.
Oh, okay. Yeah. So yeah, if you're watching this podcast, go check out my book and MEAP. Hopefully it's out really soon.
Yes, we'll leave a link. So, dude, this is awesome. I look forward to reading it. Thank you so much for your time. This has been great.
Awesome. Thank you.